inlet mass is given, inlet velocity is given, inlet pressure is given, inlet volume is given, specific volume is given, and leaving at outlet velocity is given, outlet pressure is given, outlet specific volume is given. The internal energy of air is 90 kilojoule per kg greater than that of entering air. Okay, so U1 is lesser than U2. So and it is said that U2 is 90 kilojoule per kg greater than that of entering air, means U1 plus 90 will be equals to what? U2. Okay, cooling water in the compressor jackets absorbs heat from the air at the rate of 58 kilowatt, means heat interaction with the system is 58 kilowatt. But whether it is positive or not, so we need to find out, because we need to apply to the formula, isn't it? So whatever derivation we have got at the last in the steady flow energy equation, so we will be applying those sign conventions also. Okay, so cooling water in the compressor jackets absorbs heat. So when heat is absorbed, so whether it is positive or not, okay, so it is positive, isn't it? So when heat is absorbed, so from the air at the rate of 58 kilowatts. Okay, then compute the rate of shaft work, means dW by dt we need to find out, and rate of shaft work, that is why it is dW by dt, rate of shaft work input to the air, and find the ratio of the inlet pipe diameter to outlet pipe diameter, means d1 by d2, small d1 by small d2, you need to find it out. Okay, if you draw the diagram, then it will be clear to you. So this is one air compressor. The boundary is denoted by this dotted box. Okay, this is inlet at section 11. It is denoted by section 11. Inlet is denoted by this section 11. Outlet is section 22. So here V1. Okay, this is V1. V1 means what? C1. Okay, don't confuse. This is C1. This is velocity, because 7 meter per second. C1, this is pressure. You can write capital V1 also, no problem, but sometimes it is difficult for the examiner to distinguish between this small v1 and capital V1. That is why instead of writing this capital V1 for velocity, don't use this term. So better you use C1. Okay, that also it is correct, no problem. So this is C1. P1 is given, so inlet properties are given, and the outlet properties are given. Okay, and here it is said that U2 is what? U2 is U1 plus 90. Okay, U1 plus 90 kilojoule per kg. Okay, and Q is what? Because it is absorbing heat. Oh, I told you in the question, it is absorbing heat. Okay, absorbing heat, so it is taken as minus 58 kilowatt. Okay, minus 58 kilowatt. It is absorbing heat. So when you are giving some heat to the system, okay, means it is absorbing, it is negative. Okay, and when heat is coming out, so it will be what? Oh, here it is taken as negative, no? Okay, let's see. See, this is control volume. This is control volume, means this is the open system, and this is the boundary of the system is the control surface. Okay, control. This is the boundary of the system. Okay, through which the heat and work these interacts. Now, what was our formula? Our formula was this one, dm1 by dt. Okay, so at the end of the steady flow energy equation, you can see, so time basis equation, dm1 by dt, c1 square by 2 plus z1 z h1, or h1 you can write it at the beginning, h1 plus c1 square by 2 plus z1 z, then dq by t, this term will be there, energy term will be there for heat, the energy term will be work done or will be there on the right hand side. Okay, so these things will be same thing. Okay, so here it will be dm by dm2 by dt. So instead of this h1 you can write u plus pv, because internal energy value it is given, means at the outlet the internal energy specific internal energy is greater than 90. Okay, means u2 is 90 plus u1. Okay, so that is why we will be splitting this h1 term, so u1 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 h1 plus v1 v1. So same equation I have written. Now what I will be doing, so I will rearrange this term. Okay, so how I will rearrange this term, because it is said that it is steady flow process. Okay, steady flow process. That is why dm1 by t will be equals to dm2 by t. Okay, 0.5 kg. Understood? That is why you can write like this, dm by t. So if you just rearrange this term and this term, okay, so what you can write, so you can just write it like this, u2 minus u1, because here you will get u2 minus u1. If you just subtract it, you need to give one negative sign, isn't it? So from here, if you just subtract it, so it will come to the right hand side, isn't it? So dm by dt u2 minus u1. So like this, your equation will be converted. Okay, so this is the same equation as that of this one. Okay, so just it is further arrangements of the term, okay, or the terminologies. u2 is greater than u1, then p2 v2 p1 v1. So all these things are written, and finally you need to just put the value. Okay, so this will be 0.5 kg. It is given. u2 it is 90, u1 it is yeah, u2 minus u1 will be 90, because u2 is 90 plus u1. Okay, so u2 minus u1 will be 90. Units are also written, 7 into 0.19, because this exit properties are given. p2 pressure is given, the volume is also given. This is flow work. Okay, p2 v2 at outlet, flow work at outlet. This is flow work at inlet. So all these values are given. So just you need to, c2 value is given, c1 value is given, z2 is given, z1 is given. Understood? So you need to, yeah, z2 minus z1, because they are at the same elevation. If the values are not given, then you need to consider that they are at the same elevation. Okay, means from the datum line their difference will be 0 at the same elevation. If the inlet and outlets are there, then z2 minus z1 are 0. Or if these values are not mentioned, it will be equals to 0. And as it is taken as negative, okay, means heat absorbed, it is negative, taken as negative, so it is minus of 58 kilowatt. Okay, and finally you will get this one, 122 kilowatt. Okay, so this is the answer for this first part. Okay, compute the rate of shaft work input to the air. Understood? Now you need to find out the diameter ratio d1 by d2. So for this you need to use this mass balance equation. So this is what, this w is the mass flow rate. Okay, so a1 c1. So you have studied this type of equation is in fluid mechanics, I think. Okay, I think someone has asked some doubt. Okay, so if you just apply this one, a1 c1 by v1, because what, this is a1 in continuity equation. Also you have seen this type of equation, but this is mass balance equation. Okay, so I told you on the right hand side of this equation, oh, I think it is not there. Okay, in the derivation some of the parts are there on the right hand side. I told you to strike it out, but actually that mass flow rate, okay, that mass flow rate, so it is actually AC by V. Okay, so if you just want to, yeah, that part actually. So this dm by dt mass flow rate, you can write it by AC by V. A is area multiplied velocity, okay, divided by specific volume. That is why in the conservation of mass, okay, so you can write AC by small v. Understood? So that is why I am writing here a1 c1 by v1 equals to a2 c2 by v2. Okay, so from here, so you can find out the ratio, because a1 by a2, whatever it will be the ratio, if it is a cylindrical pipe, okay, so that will be the same ratio for this d1 by d2. Okay, so after rearrangement, so you will get this is as a1 by 2 will be 3.57, as because it is d1 square by dt square, isn't it? Because pi by 4 d1 square, this area, in terms of d1, pi by 4 d1 square, and here it is pi by 4 d2 square. So pi by 4 will be cancelled out. So d1 by d2 will be under root 3.57, and you will get 1.89 as the diameter ratio, okay, of the inlet and outlet diameter. Understood? So by this way, you need to solve the equation, the questions, numerical problems of the steady flow energy equation. Okay. So what I will do, I will be sharing some problems. Okay, maybe solve problem or maybe unsolved problem, 2 or 3 solved problems and some unsolved problem to you. And in between, we will be clearing our doubts also in WhatsApp. Okay, so you can ask the question if you just want. Okay, so through WhatsApp also you can ask, and through your classroom also you can ask the doubts. And if you are not actually able to, you are having some network issue, then you can directly call me also. Okay, so sometimes I will be taking some classes, then I won't pick up the call, but if you just give me one message, then I will call you back to clarify your doubts. Okay, so thank you, dear students. So today I will not take any extra at the end. I will not take the class because already we have taken 1 hour and more amount of time. So thank you for listening. And if you have any doubt, you can ask me through WhatsApp. Okay, thank you. You can leave the meeting now.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.